Hi everyone, welcome back to my channel, Numerics with Nadia. In today's video, we are going to be classifying triangles as well as going over Pythagorean triples. If you haven't watched last week's video on the Pythagorean Theorem, I would highly encourage you guys to watch that one first before watching this one. As for today's lesson, we will, of course, still review the Pythagorean Theorem, and then we will go through some common Pythagorean triples just so you guys can recognize them moving forward. And then we will work through classifying triangles. So we're going to classify them by their angles, either acute, obtuse, or right. And then, as always, we will end off with some practice problems. But to start off, let's review the Pythagorean Theorem. For those of you who watched last week's video, this will be a review for you, and you will recognize this diagram on our right. We have a right triangle, we have three sides, A, B, and C, and the Pythagorean Theorem formula is a squared plus b squared equals c squared. Now, the definition of the formula in words we will go over next. The Pythagorean theorem is the sum of the squares of the sides of a right triangle equals the square of the hypotenuse, right? So if A and B are our sides of the right triangle, them squared will equal the hypotenuse squared. So now that we've reviewed what the Pythagorean theorem is, what are Pythagorean triples? I have a picture of the most common ones and their multiples on the bottom here. But what is a Pythagorean triple? A Pythagorean triple is a set of three positive integers, a, b, and c, that satisfy the Pythagorean theorem, right? Or that satisfy the equation a squared plus b squared equals c squared. So all of these common Pythagorean triples are going to start with their base. So it's either going to be 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25, or any multiple of those core three numbers. So the Pythagorean theorem is when a squared plus b squared equals c squared. But what will happen if that's not the case? What happens if a squared plus b squared does not equal c squared? Well, that will carry us into our next section of today's lesson. And in this section, we're going to learn how to classify triangles based off of the Pythagorean theorem. So now that we know the Pythagorean theorem as well as Pythagorean triples, it will really help us here to be able to classify these triangles. So as we know, if a squared plus b squared equals c squared, well, that's a right triangle. But what if a squared plus b squared is greater than c squared? That would be classified as an acute triangle because the hypotenuse's length is less than the sum of the other two legs. And for obtuse, the formula would be a squared plus b squared is less than c squared, meaning the hypotenuse is longer than the sum of the square of the two legs. So now that we have all three of these classifications and equations down, I would highly recommend copying these in your notebooks because this is what we're going to be practicing in our practice section. So once you have that down in your notebook, we will move on to our practice section for today. The directions for our practice section say to assume the segment lengths form a triangle. Sometimes we would have to prove that the side lengths would be a triangle, but in this case, we're going to assume that they are a triangle. All we're going to do is classify them. So is the triangle acute, right, or obtuse? So we're going to be given three side lengths. We're going to assume that the segment lengths form a triangle, and then we will classify them as either acute, right, or obtuse using the formulas that we just did in our diagram. So for number one, we have the side lengths 10, 11, and 14. So these go in order of A, B, and C. So that would make A equal to 10, B equal to 11, and C equal to 14. So now we'll plug this into our Pythagorean theorem. It would be 10 squared plus 11 squared equals 14 squared. We know that 10 squared is 100. we know that 11 squared is 121, and we know that 14 squared is 196. So we know that 100 plus 121, well, that gives us 221. And obviously 221 is greater than 196. So since it is greater, that would make this triangle acute. Now we will move on to our second practice problem for today. The side lengths for this one are 6, 8, and 10. So that would mean that A equals 6, B equals 8, and C equals 10. We'll plug that into our Pythagorean theorem again. We would have 6 squared plus 8 squared equals 10 squared. We know that 6 squared is 36, 8 squared is 64, and 10 squared is 100. So when we do 36 plus 64, we get 100. So since these are equal, we can classify these side lengths as a right triangle, and this is a Pythagorean triple. Now we will move on to our third practice problem for today. For number 3, we have the side lengths as decimals, which is okay, you can use a calculator. We have 4.3, 5.2, and 6.1. So that would make A equal to 4.3, B equal to 5.2, and C equal to 6.1. If we plug that into our Pythagorean theorem, we would get 4.3 squared plus 5.2 squared equals 6.1 squared. When we calculate this in our calculator, we end up getting 18.49 plus 27.04 equals 37.21. So then if we add up the 18.49 and the 27.04, we get 45.53, and that's obviously greater than 37.21. So number 3 would also be an acute triangle. And now we will get on to our fourth and final practice problem for today. For this one, our side lengths are 15, 20, and 26. So that would mean that A equals 15, B equals 20, and C equals 26. Just like all the steps above, we will plug this into our Pythagorean theorem. So that would be 15 squared plus 20 squared equals 26 squared. We know that 15 squared is 225. We know that 20 squared is 400. So it would be 225 plus 400 equals 26 squared is 676. We know that 225 plus 400 is going to be 625, and 625 is less than 676, so that would make number 4 an obtuse triangle. So in all of our practice examples, we had an acute example, a right example, as well as an obtuse example. So that concludes all of our practice questions for today. I hope you guys enjoyed today's lesson. Please feel free to like the video if you enjoyed it, comment any questions or any other video topics you would like to see down below, subscribe if you haven't already, share this video with a friend, and I will see you guys next time.